types of vectors. In the types of vector, we are having different type of vectors. First, we can say equal vector. Equal vectors. Equal vectors means whenever two vector quantities are said to be equal, so always remember their magnitude as well as direction must be same. So, two vectors will be equal only when their magnitude and directions are same. Two vectors will be equal only when their magnitude and direction are same. If anything is not same, either magnitude or direction, then these are not called as a equal vector. So, if these vector we have to define with a arrow. So, vector A, let this is vector B. So, A must be equal to B when their length of arrow should be same, and those two should represent same physical quantity. So, it does not mean that their magnitude is same, but they are representing different physical quantity, then can be said the same vector. No, just like for example, if vector A is given, so let vector A is here 5 meter east and vector B is given 5 meter per second east. In this case see, both having the same magnitude, both having same direction, but one of the vector have unit or meter, another vector have unit or meter per second. It means vector A is your displacement, while vector B is your velocity. So, although these two having same magnitude, same direction, but their units are different. These units are different means that represent your different physical quantity. If these are representing different physical quantity, then it cannot be same. So, main point here is two vectors will be equal only when those should represent same physical quantity, same magnitude. Same physical quantity means clear, the magnitude is same and unit is same, as well as their direction should be also same. So, all the three parameters, magnitude, unit and direction, if all are equal, then it is called your equal vectors. Now, parallel vectors. Parallel vectors. Two vectors will be parallel when their directions are same. Two or more than two vectors called parallel vector, when their directions are same. When their directions are same, so their magnitude as well as their units can be different. So, see, all those vectors which are having same direction, those can be said as a parallel. Just like if I am talking about these two conditions, A and B, these are the different physical quantity, but their directions are same. If the directions are same, then we can say this position and velocity are parallel to each other. So, such type of vectors which are having same direction irrespective of their magnitude as well as unit, those two quantity can be your different physical quantity, will be in the will call as a parallel vectors when they are having same direction. Third is your anti-parallel vectors. Anti-parallel vectors. The vectors are in opposite direction. The vectors which are in opposite direction called anti-parallel vectors. Anti-parallel vectors. So, any two vectors whose direction are just reverse, it means one of the vector like this, another here in this side, then these two are called as anti-parallel vector. Their magnitude may be different, and they can represent different physical quantity also. So, to become a parallel or anti-parallel, only we have to see the directions. If directions are same, then the parallel vector, and if directions are opposite, then called anti-parallel vectors. Next one, unit vectors. The vectors which are having unit magnitude are called unit vectors. The vectors which are having unit magnitude the vectors which are having unit magnitude called unit vectors. These represent direction. These represent direction, and if these are multiplied with any other quantity, they won't change the quantity. They won't change the quantity. So, how we are representing? Let A is a vector. A is a vector. So, vector means it has magnitude and direction. So, its magnitude is your mod A. So, vector A can be written as mod of A and A cap. Here A cap. So, this term is called your cap. So, when we are making or writing a vector with A and cap, A cap represent. So, A cap represent unit vector of vector A. So, A cap is nothing vector A by modulus A. So, whenever we have to represent a unit vector, so what we will do? We will write the magnitude of that vector and we will divide with its magnitude. So, in our orthogonal coordinate system, coordinate system x, y and z axis are represented with I cap, j cap and k cap. These are unit vectors. So, I cap represent x axis direction, j cap represent y axis direction and k cap represent z axis direction. So, that is why in our orthogonal unit vector, this is your x axis, y axis and z axis. So, if any of the particle is moving or having that direction x axis, so how to represent that? We can say x means I cap, y means j cap and z means here k cap. So, if any of the vector is along this direction along x axis, then we can say I cap when along y, j cap when along z, k cap. So, these are the representation of your orthogonal unit vectors in terms of I, j and k. So, whenever the I cap have magnitude your 1 and its direction your 5. So, let for example, so suppose let particle have velocity 5 I cap. A particle have velocity 5 I cap meter per second. So, what does it mean? So, 5 I have multiplied 5 with I cap. I cap it means as per here the vector in velocity is your the vector A become velocity. So, velocity normally we are representing with symbol V. So, V is your 5 I cap and meter per second. So, see the comparison from here. So, let vector A have magnitude your mod A and A cap represent direction. Same thing here, velocity V 5 represent its magnitude, I cap represent just like A cap. So, I cap is defined along x axis. So, we can say from this representation we can easily say the particle is moving with a speed 5 meter per second towards which direction? Towards the x axis or towards the I cap direction. So, this is the method of representation in orthogonal coordinate system. Now, come to the next point, null vector. Null vector means a vector which is having zero magnitude. Zero magnitude is known as null vector. A vector having zero magnitude is known as null vector. For example, let this is a particle or a body kept on a horizontal surface. If 5 Newton force acting in this direction F1 and the same 5 Newton force acting from the opposite direction F2. So, net force on the body. So, if I am writing here net force F is equal to here, see here, if the same thing we are representing in our coordinate system like this, I cap, j cap and k cap. So, we can write F1 is equal to your 5 and this direction your I cap, 5 I cap, F2 we can say 5 minus I cap because the direction reverse. So, F is equal to your 0 I cap. So, this represent here the magnitude of the force is your 0, but direction. So, whenever direction is your, if I am writing here I cap, so in fact direction of null vector cannot be defined. So, best way is say we should write F is equal to 0 and undefined direction, undefined direction. So, a null vector has 0 magnitude and their direction here undefined. Next is the collinear vector. Collinear vector. Collinear means the vectors which are in the same line. The vectors, as the name collinear, the vectors which are acting along same line, the vectors which are acting along same line are called or known as collinear vectors. Collinear vector. For example, see, let this is a body kept on a horizontal surface. So, in this body, if we are observing the forces, one force applied by the gravity, that your mg, another force by the surface, that is called normal. So, this normal force and gravity force both are acting along the same line. So, these are called your collinear vectors. So, here n and mg are collinear vectors. So, these forces are acting along the same line of action. As well as these forces can be also called as a anti-parallel vectors, because direction of n and mg are opposite. So, all your parallel as well as anti-parallel vectors can be studied as a collinear vectors. Next is the coplanar vectors. Coplanar vectors, the vectors which are acting along the same line, vectors which are acting along same line or along same plane. The vectors which are acting along same plane are known as coplanar vectors known as coplanar vectors. For example, see, suppose this is our a body kept like this. Let this your x axis, this your y axis, and this your z axis. Our body is kept in your xy plane. The one force acting at F1 in this direction, another force here F2 in this direction, third force may be here F3. So, here F1, F2, F3, all the three forces are acting in a same plane. So, here forces F1, F2 and F3 are acting in same plane, that is xy plane, So, these forces are called, coplanar, and since these are the vector quantity, so these type of vectors are called coplanar vectors. So, these are the few types of vector. Now, come to the mathematical application of vectors.